Alright, this is lesson 2.10 of our Pre-Calc 11 class. Unit 2 is called Polynomials. Lesson 10 is called Axis of Symmetry and Vertex. What we're going to talk about is how to find the axis of symmetry from a quadratic equation and how to find the vertex as well. Axis of symmetry is that vertical line that cuts right through the center of the parabola and it intersects the parabola at the vertex. It cuts the parabola into two symmetrical halves. If you fold the parabola over on the axis of symmetry, the two halves will be equal to each other, or right on top of each other. The equation to find the axis of symmetry is the first part of the quadratic equation, negative b over 2a, which we talked about briefly in the last video at the end. If ax squared plus bx plus c equals y is our quadratic equation, x equals negative b over 2a is the axis of symmetry. We can change the c value, we can change the b value, and we can change the a value. No matter what, the axis of symmetry is still negative b over 2a. So we can find the axis of symmetry from examples a, b, and c. Take a moment, make sure those make sense to you. Alright, so the vertex, again, if we know the axis of symmetry, the vertex is where the axis of symmetry intersects the parabola. So the x value of the vertex is going to be the same number as the axis of symmetry. X equals negative b over 2a. We take that number, we plug it in for x, and we evaluate for y. That y value will be the y value of our vertex. So this right here might look complicated, but what it means is just what I said. You find the negative b over 2a, plug that in, so example a is negative 2, plug that negative 2 in for x, and solve, we get negative 1. So y of b, or negative b over 2a, is just negative 1. We can do that for example b. Our axis of symmetry is x equals 4. So 4 is the x value of a vertex. Plug in 4 for x, we get y equals negative 4. So 4, negative 4 is the vertex for this one. We could graph that to verify it. 4, negative 2, 60. Sorry, 4, negative 32, 60. A is 4, B is negative 32, and C is 60. We see our vertex right here is 4, negative 4. That matches up with this right here. Okay, we could graph the vertex. We could add a point. Let's go right here. We'll go bracket negative b over 2a for x value. For our y value, we'll go, I don't think we can write y of negative b over 2a in here, but we'll give it a try. Boom, boom. Nope, doesn't like it. What we're going to do is, we're going to write this right here. And we're going to take the x value and we're going to replace x with negative b over 2a everywhere. Right there. So now we have negative b over 2a. We have a times negative b over 2a squared plus b times negative b over 2a plus c. We're going to label that in our graph. There it is right there. No matter what a, b, and c are, whoa, that's a little crazy. Let's rein it in. So the vertex is always following. There we go. Notice the purple dot's always on the vertex. That's cool. Okay, that's vertex. Examples. If I want to graph this quadratic equation as a parabola, what I'm going to do is I'm going to start with the axis of symmetry. We can calculate the axis of symmetry as being x equals 3. To adequately graph this parabola, I'm going to suggest that we need at least 5 points on our graph. If we start with the axis of symmetry, I'm going to draw a table. I'm going to put the axis of symmetry in the middle of 5 rows. I'm going to count 1, 2 before it and 1, 2 after it. So 1, 2, 3, 4, 5 are all the x values that we're going to plot to graph this parabola. I'm going to take the first 3 x values, 1, 2, and 3. I'm going to plug them into our expression. And I apologize for the really large exponent of 2 and the really large coefficient of x, or of 6. My dead spot on my surface is right here. We don't have a budget for a new surface. If you want to buy me one, you know what to give me for Christmas. Yeah. Anyways, 1, 2, and 3 we're going to plug in for x. We're going to evaluate and get y values of 0, -3, and -4 respectively. Now we don't have to evaluate 4 and 5 unless we think we made a mistake. We don't have to evaluate those ones because we found y values all the way up to the axis of symmetry, which means we found that 1 goes to 0, 2 goes to -3, and 3 goes to -4. Well, because this is the axis of symmetry and 3, -4 is the vertex, and that's where we started from, that was our beginning thing, we know that the right side has to be symmetrical. So I know that 4 has to go to -3 and 5 has to go to 0. You can plug 4 in and you'll get -3. You can plug 5 in and you'll get 0. Or you could just write those numbers down because you know it's going to mirror. We now have 5 points you can plot, which will give us a pretty accurate sketch of our parabola. So again, the procedure is standard form, find the axis of symmetry, find 2 points before it, so that we can find 2 points after it, giving us 5 points to graph the parabola. Alright, takeaways. We can now calculate the axis of symmetry and the vertex of a quadratic equation in standard form. That sounds impressive. Go tell your parents that. We can also graph a quadratic in standard form by first finding the axis of symmetry, the vertex, and then 2 points before, which gives us 2 points after. Whoop whoop. That's cool.